Mechanism of respiration, lung volumes and lung capacities. Lung volumes include tidal volume, inspiratory reserve volume, expiratory reserve volume, residual volume. Lung capacities include vital capacity, inspiratory capacity, functional residual capacity, total lung capacity. Tidal volume. Volume of air that moves into the lungs with each inspiration or amount of air that moves out with each expiration. The volume of air that moves into the lung is usually equal to the amount of air that moves out with each expiration. Here, it is not that we are adding the amount of air which we inspire to that of the amount of air that is being expired. It is only one value. It is about 0.5 liters in an adult. Inspiratory reserve volume. Total volume of air inspired with the maximal inspiratory effort. It is the volume of air which you take in when you take a deep breath. That is, it is about 3 to 3.3 liters. Expiratory reserve volume. It is the additional volume of air that can be expired out forcefully after normal expiration. That is, it is about 1000 ml. Residual volume. It is the air left in the lung after a maximal expiratory effort. Even after expiration, there will be some amount of air that is trapped inside the lungs, and this air is called as residual volume. It is about 1.2 to 1.1 liters. Lung capacity. It includes two or more lung volumes. Vital capacity. It is the greatest amount of air that can be expired after a maximal inspiratory effort. That is, take in a normal inspiration, continue inhaling the air deeply, then expire the air normally. The volume of air involved in all these steps together is vital capacity. It is nothing but inspiratory reserve volume plus tidal volume plus expiratory reserve volume. It is about 4 to 8 liters. Factors affecting the vital capacity. Physiologically, males have a higher vital capacity. Vital capacity decreases with age due to gradual loss of elasticity of lungs. Vital capacity is maximum when in standing position. During pregnancy, vital capacity decreases due to the diaphragm being pushed up. Vital capacity decreases due to diseases such as pulmonary fibrosis, emphysema, pleural effusion, etc. Ascites too decreases the vital capacity due to the pressure pushing the diaphragm upwards. Total lung capacity. It is the volume of air present in the lung after a deep inspiration. That is, you inhale normally, then continue a deep inspiration. The total volume of air inside the lungs during this movement is total lung capacity. It is nothing but all the four volumes. That is, tidal volume plus inspiratory reserve volume plus expiratory reserve volume plus residual volume. It is about 6 liters. Inspiratory capacity, amount of air that a person can breathe beginning at resting expiratory level and distending the lungs to maximum amount. It is nothing but inhaling of air normally and then continuing with a deep inspiration. Total amount of air that has taken part in this inspiratory or during this inhalation is called inspiratory capacity. It is nothing but inspiratory reserve volume plus the tidal volume. Functional residual capacity. It is the amount of air remaining in the lung at the end of normal expiration. After a normal expiration, you still have or you still can expire more or by expiring forcefully. When you don't do that, then that air will remain in the lung. Hence, the expiratory residual volume and the residual volume which gets trapped in the lung even after a forceful expiration. Both together form the functional residual capacity. Pulmonary function test. They are useful in assessing the functional status of the respiratory system. Test involves the measurement of lung volumes and capacities. It is carried out by an instrument called spirogram, which does a graphical record of respiratory movement traced on a revolving drum. In this instrument, patient is made to blow in an area and the volume and capacity will be noted on a drum. Graphical results will be given. Timed vital capacity. This is a dynamic lung function test where the subject is asked to inspire and expire forcefully and rapidly into a recording spirometer, and total volume of air thus expired is timed. In normal individuals, the forced expiratory volume in first second is about 83%, in the second it is 95%, and in the third second it is 100%. This in each second is calculated and plotted on a graph against time. Pulmonary ventilation is the amount of air inspired per minute. Alveolar ventilation is the volume of air that participates in exchange of oxygen and carbon dioxide. It is about 350 ml. Dead space air. Volume of air present in the respiratory passage and does not take part in gaseous exchange. It is about 150 ml. When you are inhaling, exhaling, when the gases are being exchanged from the alveolar into the blood vessels, none of these functions will be done by this dead space air. It is just like a lazy air in the respiratory tract. And this is the summary of this video.